Good afternoon. It's Sunday, I think the 4th, maybe, of September here in southeast Oklahoma. And I just wanted to slide in one more, maybe brief uh, video and go through some calculations with you before we get into the Module 9 assignment. So I'll have these put up directly. Uh, uh, I won't be taking off tomorrow for Labor Day, so I will have them up during for you to start on Labor Day if you want to. And so I got one problem. I used my little, I call it a worksheet for calculations I sent out. I wanted to say a few words right quick because uh, we'll be moving on to other courses. I'm sure we'll see each other again, but I want you to I want to talk to you about the textbook and this course that we just had. This textbook has over 281 pages covering hydraulics. So, so I think we used about 35 pages during this course from the textbook. But we did bring in some outside sources to help us along and some screenshots of some YouTube videos that I like. So we touched on some subjects such as the fundamentals like Pascal's law, Bernoulli's principle, and a few disadvantages, advantages. We talked about hydraulic terms. But I think the work we did, or the subject matter we went over in the little section that was we're talking about the relationships between pressure and flow. I think that was a good, I think it wasn't a chapter, it was a section. And I think it would be good for you to go back through that. Uh, and this is not an assignment, but just to, before you put this course on a shelf and just go through that. There's so many, oh, I don't know what the word is, but there's just a lot of concepts and things that are thrown at you in this thing. Pages 562 to 564, starting with those operation of a basic hydraulic system. It takes us through the components and some calculations needed to the beginnings of being able to put together a simple hydraulic system such as a wood splitter. And I recommend going back through it and taking another look at it again and see if you can come to terms with what the book is saying. It has some examples of, one example of calculating horsepower. Probably have one question on that. That's a simple calculation. However, it's a very important one. None of this stuff is going to work unless you have the adequate horsepower to in the prime mover to turn the pump to produce the flow to create the pressure to actuate the actuator. So all of this stuff is important. It's just a little bit sometimes challenging to put it all together in a conscious stream in my mind, or maybe not for you, but there's some concepts that really take a little reading in here. And I feel like that this was designed to prepare students to get into the major stuff that also is in the book. And certainly if you own the book, you may have enough, and I bet you do, just from this course, that you will be able to go a long way if you desire to in that textbook. So, don't hesitate. And, even I want you to be able to go into an interview with this knowledge and says, well, what did you discuss in hydraulics? Be able to respond to that. You don't have to explain everything to the interviewer, but if he knows what at least you were exposed to, then I'm sure he figures you came out with a good deal of it. So be able to articulate that to him. So you just go back through this chapter and look at the topics that we went through and briefly go on, but prepare yourself because you're looking for a career, the job, the breakthrough, I'm assuming you want to move on. So they're going to be looking for people other than one and done. You had this course, you put it behind you, and and you moved on. Just retain, the retention of knowledge is a great thing. So I'll get off my soapbox and I'll start talking about this worksheet I have here, and it actually helped me. One thing it helped me do was to, make things a little neater, and it I got it broke down into basic, and the book breaks it down like this. The first thing you want to do is list all your givens, your piston diameter, your rod diameter, your stroke, your pump flow rate. We know we're going to need all of those because we're going to end up calculating cycle time, and all of those are required. Now I made up this 5 inch and 2.5 for the rod, 24 for the stroke, 15 for the gallons per minute. And just to shift gears a little bit and show us that it doesn't matter what the numbers are, we can still do it. But again, the first thing I asked myself and you is to calculate the volume and the extended uh, end of the pump, the when the pump is extended. And first thing I did was put down area for the piston. So then I used the area I like to use, pi times the diameter squared, and I worked it through, and I did it step by step, calculate, and you can see some erasure marks there that I made a mistake, but came back and corrected them. And I came up with the area as 19.64 square inches. So I wrote that down there. Now the next thing I did was I took that area and I'm going to calculate volume. And to do that, I have to, of that extension, I have to take to get to the volume, I got the area, I got to take the area, multiply it times the area of the piston, and multiply it times the stroke of the piston, 24. So I did that right here. I took that 19.64 inches squared times 24, and I came up with 471.36 cubic inches. So now I've got my volume right here, and I'll be using it later on. I got my volume for the extended. Then I have my number 3, calculate the volume for retract. Now, retract has a little additional thing down here, but I found this is a good way to do it. So I say the volume for retract is the volume of extend minus the volume of the rod. And that's essentially what you're doing. As you can see up here, the volume for the extend is just the area times the piston times stroke. So I came up with that volume for the extend. So here I'm going to calculate the volume for retract, which is extend, the volume of extend minus the volume of the rod. So I did my calculations and I came up with 4.91 square inches for the area of the rod, which was a 2.5 inch rod. And as you can see, I checked myself as I went through here, got rid of my square, unsquared it, and then I get down here to the volume, and the volume is going to be my area, which I found to be 4.91 inches squared times 24, that's my stroke, and that gave me 117.84 cubic inches, and that's the volume of the rod. So again, to get my volume of retract, that's when the rod comes in. I take my volume of extend right here, take my volume of extend, where'd it go? Volume of the rod my volume of extend, here it is, way up here, 471.36 cubic inches, and I subtract my volume of the rod, which is 117.84 cubic inches, and that gives me 353.52 cubic inches, and that's the volume of my retract when the rod is retracted. I have that volume. So uh, I'm sorry, 353, and then the extend is 471. I'm looking to compare it and make sure I do see some differences. That's just like a little physical check. So the next thing I do, in other words, I always expect my volume of retract to be a little bit less than my volume of extend, and I also usually expect my volume, my speed of retract, my cycle time for retract is a little bit faster than my cycle time for extend, and that is because of it filling up the volumes. The rod takes up room, so it doesn't take long to fill up the volume here. It does take a little bit longer to fill the volume, and filling the volume is part of your cycle time, the volume of the cylinder. So the next thing I want to do is, and I didn't, when I first looked at these, I started calculating too early. I could come out with the same answer, but it made it simpler if I do it at this point. Convert my units right here on step 4 from cubic inches to gallons. And the formula for that is there are 231 cubic inches in 1 gallon, so the volume in cubic inches divided by 231 gives you the volume in gallons. So the volume for extend, cubic inches to gallons, is 471.36 divided by 231, and that equals 2.04 gallons. And so the extension volume in gallons, that's the extension volume in gallons, 2.04. I will need that in my cycle time calculation, so I don't want to have to hunt for it again like I did that extension volume, but I found it. And so here we go for volume and retract, is you take your cubic inches divided by 231, and you'll come up with 353.52 cubic inches. Divide that by 231 cubic inches in 1 gallon, and you get 1.53 gallons for my cycle time. I'm sorry, for my extend and retract, and for my retract in gallons. Now, moving on to cycle time. The cycle time extend is in gallons. The word in. You put in gallons here. You put your gallons here for your volume, and you divide it by your flow rate in gallons. Let's see, the volume in gallons divided by flow rate in gallons per minute. So that's what that is right here, gallons per minute. And that's a given, by the way. It's not up here, but I should have it up here. I did have it. There it is. Flow rate, gallon per minute. So we take that for the cycle time extend, we take our 2.04 gallons and divide it by the flow rate of 15 gallons per minute, and that equals 0.36, and you multiply that times 60, and that gives you 8.16 seconds. And that's what this conversion, this guy right here, this 60, is converting it to seconds from minutes, because you got gallons per minute here. You multiply it by 60, and then you got time in seconds. So the cycle time retract equals volume retract in gallons, which is 353.52, which is 1.5, that was my cubic inches, 1.53 gallons divided by 15 is 0.102 times 60, and there we go. We got 6 and 1200 seconds for your retract time. And that's it, guys. I've bounced around a little bit, but it helps me to put things I need to remember, but some things I don't highlight because once I get them, I won't need them unless I want to recalculate something. So that's in a nutshell. If you're not comfortable working through these problems, we'll have one problem, uh, probably in at least one problem in the assignment, and the assignment is like in the essay form, and you'll just calculate this, and you can upload it, or you can, if you are good with the text box stuff, you can type it out in there. But it's fine to just write it out. I sent you guys some of these forms if you want to use them, and I believe that that's all we're going to have. There was a quiz, I think we had some questions about in module 8, but I took that out. I don't want any more quizzes. So it's going to be important for you to do this problem because, as you can see, you're just going to do a couple of things, and I can evaluate you. Don't leave anything blank. Don't not do anything, because I need something to give you. If I see you, if you do your work just like I did, if you just put down an answer and it's wrong, I have no recourse. But if I see you doing your work and I see where you made a mistake and you got a different answer than I got, then I can say, oh, he made a mistake. And, heaven forbid, I can say, oops, I made a mistake. And I'm sure you guys will catch that. So, any questions, same as usual, if you need to contact me, just give me a call or text, and I'll be around. Don't hesitate. And have a good Labor Day. Thank you.